everybody. Morgan here, sitting back, drinking a beer, ready to get my tutorial on. I'm here today to teach you guys how to create a scatterplot graph in Excel with the data that you collected in lab on measuring the density of copper. Now the reason that I want you to do this in Excel is because Excel is, it's a life skill learning this program. It can do so much for you, and it doesn't matter whether you're an accountant or you own your own business or you manage a sports team or you run a classroom like I do. If you come into contact with names and numbers and data, you need a place to store it, and you need a place where you can do repetitive calculations and make all your data look pretty. That is Excel, and I want to show you just a itty-bitty fraction of what this program can do and hopefully give you a glimpse into how it can be useful to you. So what I have in front of me here is some practice data from the back end of your Lab 1 measurements and density. And just as a reminder, what you did was you took a cylinder, a graduated cylinder, and you filled it with water, about halfway full, 5-ish mils. And you recorded the mass and the volume of that cylinder and the water inside. So this trial 0 here, this is the trial that has no copper in it. It's what I'm going to call my tare volume and my tare mass. And then I put a little bit of copper in that cylinder, and the mass goes up and the volume goes up, and I put a little bit more copper in, a little bit more, a little bit more, a little bit more, and I end up with a series of what will ultimately be XY data points. Now the first thing I need to do is I need to subtract the tare volume and the tare mass from all of these. I don't want the weight of the cylinder and the water, I only want the weight of the copper that's contained within. So I'm going to create a new column here. I'll call this one the volume of my copper. Milliliters, megaliters, megaliters, milliliters. There we go. And the mass of my copper in grams. And Excel is ultimately just a database storage program. So every one of these boxes stores information. So if I say 3 plus sign 2, it just keeps that there. But if I put equals, it turns this box into a calculator. So now if I type 3 plus 2, it says, oh, that's a function. 3 plus 2 is equal to 5. Well, I don't need that calculation. What I need is I need to say this box right here, B2, minus 5.02, my tare volume. Well, it comes out to 0 because I had no volume of copper. I'm going to do the same thing over here. I'm going to say the initial mass in trial 0 minus my tare mass. That's 7501. Okay, 0, 0, not really useful. But if I take this volume and I click this little green square down here in the corner and I drag it down, what it does is it updates anything I had as a reference. Here my reference is B2. Anything I had as a reference, when I drag down, Excel will automatically update that reference cell. So my first one was referencing B2, and I dragged down to reference B3, and it does the same calculation. Take B3 and subtract from it my tare volume. And if I keep dragging down, Excel will keep updating over and over and over again that referenced cell. So I don't have to do this calculation again and again and again. I'm going to do the same thing over here on my mass of copper. Grab that little green square, grab all the way down, and now I have the mass and volume of copper at each sequential step. Now from this, I could calculate a density if I so chose. I'm going to call this the density of copper in grams per milliliter. And my density is grams divided by milliliters. So I'm going to take F2 divide by E2. I get it divided by 0 error because I took 0 divided by 0. But when I grab this little green square and I drag down, it repeats that calculation. So this one now says F3 divided by E3 and tells me that the density at this step in my measurements was 23.4 grams per mil. That's a pretty bad density considering the real density of copper is around 9. I'm going to keep dragging down, get the density at all these sequential steps, and I'm going to scoot these digits down a little bit so they look a little cleaner. There we go. And there I have a whole bunch of densities. Another thing that Excel can do for me is it has all the stuff that a TI calculator has. It has averages and standard deviations and all of my statistical functions. All I have to do is know what the code is. So I'm going to create an average. To do that, I'm going to type equals average open bracket. And then I can go through and select all the data that I want to take an average of. In this case, G3 through G7. Close bracket, enter, and there you have it. 13.1 is the average of all of my data. Now, that's not a very good density for my copper. And the reason it's not so good is because it's weighting each one of these dots equally, and some are better than others. So to get a better density output, what we want to do is we want to plot this information so that it is an XY, XY, XY points. To do that, I'm going to select all this data, and up at the top here, by the way, if you guys have a different version of Excel, if you have 2010, what do I have? I have 2013. If you have 2010 or 2017, it'll look a smidge different, but pretty much the same. So highlight all this data, come up here to insert, and there's all these charts right here. I want to insert a scatter plot, and I want a scatter plot with nothing fancy on it, just the dots. Let me zoom out so you can actually see this guy. There's my chart. I'm going to move this thing to its own tab. So right click it, move chart, and I'm going to put it in a new sheet, and I'll just call it graph. There we go, graph, and I have this one that I already previously named data, and there we go, I have a beautiful graph. It's called chart title. It doesn't have any axes labels yet, but I can add that stuff in. The first thing I want to do to this graph is I want to put a trend line on this thing, a best fit line. If I click these little dots and right click them, there's an option to add trend line. It'll bring up this menu on the right. And the first thing it has is it lets me pick what kind of relationship do I think the mass and the volume have. Because ultimately what I'm doing here is I'm trying to plot as the mass goes up, how does the volume respond? Or inversely, as the volume goes up, how does the mass respond? I think that my relationship here is linear. As volume goes up, mass linearly goes up with it. So linear line. And then I have a couple of options down here. I want to display an equation on the chart, and I want to display an r² value on that chart, and I'm done with this. So let me see if I can't make this little equation bigger. There we go. Huge. This equation is exactly what I wanted. It's my y equals mx plus b for this linear line, and recall that this first number here is my slope. It's the rise over the run, or in this case my y-axis is grams and my x-axis is milliliters, so it's the grams over the milliliters. That's my density. And the target I was shooting for was about 8.94, 8.96, somewhere around there. I got 9.04. That's really great. I don't know why I'm getting so many decimals, but I'm not going to worry about that right now. I also have this plus B. That's because my line, my best fit line, is hitting at about 1.09. If I wanted to, I could come to this and format the trend line and tell it to set the intercept. And I could force it to go through 0. It changes my equation, so the density is not quite as good as it used to be, and my r² value is not quite as good as it used to be. But it forces the line to hit the 0 right at the y-intercept. I'm not going to do that. I'm just going to leave it as it was. By the way, this r² value, if you guys haven't taken stats or it's been a while, this number is telling me how well my dots fit on this line. If all of my dots fit perfectly on this straight line, I would have an r² value of 1. If my dots were totally chaotic and they didn't fit this line at all, I would have an r² of 0. So at 0.986, it says your dots are pretty close to that line. We'll go ahead and call it a day. The next thing I want to do is I want to add some trend lines. So make sure this chart is selected, and I'm going to come up here to chart tools. I have design and format. If I come to design, over here there's this chart element, and I have axis titles. I'm going to add a primary, and I'm going to add a primary horizontal and a primary vertical axis. These axes I'm going to label. Down here I have the volume of copper in milliliters. And on the side here is my mass. So I'm the mass of copper. Mass. Come on. Mass of copper. In grams. And my chart title here, I'm going to call this the density of copper shot. The last thing I want to do here, I can select some different pretty graphs choices, predetermined graphs if I would like. Ooh, black. Ooh, nice. I kind of like this blueprint thing. I'm going to stick with that. And there we go. I have a beautiful graph. And what this graph is telling me is it says the slope of your line is this 9.0472. That's the density, and that's what I want. That it did without any work. I can do this manually. If I did it manually, I'd draw a line that tries to go through all these dots, and then I have to figure out what's my run, what's my rise, divide my rise by my run, and then figure out what my y-intercept is. Excel does all this stuff for me without me having to think, so it saves me a little bit of brain power. I'm going to make this formula a little bit bigger so it's easy to read. Move it around so it's not really lines. And there we go. That's my graph. Last thing I want to do here is I want to save this guy. I'm going to save it as a PDF. And I'm I'm just going to call it copper density graph. And you probably also want to save it as an Excel file so that you have the master document that you can edit later on. And now I want to go open that. Where did it go? I lost it. Oh no. Oh, found it. And here it is, our PDF of our graph. It looks exactly the same as my other graph, but this one is effectively printed on paper. It's uneditable now, so I can't muss up any of the bits that I have. This is what I want you to submit to Canvas, is this PDF version of your beautified graph with the background of your choice, the y equals mx plus b on there, the r squared on there, everything properly labeled. I hope you guys learned something about how to use Excel and what Excel is for. And I hope you can find some reason to use it in the future, because it is a fabulously powerful tool that can do so much for you if you take the time to learn to use it. Okay. Good night, everybody.